Up until now, you learned how we perform a very simple, straightforward calculation with EPWpy, where we start with the material definition, we execute all these blocks, and eventually perform an EPW calculation. In the last section, we performed an EPW calculation for optical properties, and this was performed using the keywords such as the omega and the L indirect abs, which is also an input keyword for general EPW calculation. Now, next we basically perform a more complicated calculation where we require a bit of interchange of the blocks. So what is this calculation? So here the calculation seems simple, is where we start with the material, we perform a simple SCF and phonon calculations without any kind of a spin orbit coupling. So in certain material systems, you require spin orbit coupling to define the electronic structure. However, the phonon structure doesn't require that, and adding spin orbit coupling and performing phonon calculations with that will actually be very time consuming. So in those kind of situations, the user just wants to perform simple phonon calculations, and then he wants to perform a spin orbit coupling calculation for only the electronic structure, and then both of these are inputted to the EPW calculation. Here you can see that the block structure, unlike the previous structure where it was just a simple straight line, is more complicated because we have these two blocks, then we have another block to execute. Now, in EPWpy, you can basically convert this block into cells and define them the numbers, and according to the number of printed here, you can execute these blocks, and the input will actually be handled by EPWpy, and the data will be handled accordingly. So for example, if I perform an SCF pH calculation, and then again I add a block with SCF spin orbit coupling calculation and go to the EPW calculation, that should work fine. And this is how exactly we do that. We do that by starting from the material definition. So this is just the material definition that we had. We then have the SCF calculation without any kind of spin orbit coupling, as in the input you can see. We performed a phonon calculation, but now we have added a calculation of SCF with spin orbit coupling. How did we do that? We added these two tags, non-collinear true, L spin orb true, and these two tags basically switch on the spin orbit coupling calculation in the SCF in pw.x. And with this, we can perform a SCF calculation. So we add the spin orbit coupling block, something that it looks like this, and then we execute this block, and now the SCF calculation is performed with the spin orbit coupling. And from here, if I go to the NSCF calculation, since I have added the block, something like this, so here I have SCF SOC, and now if I perform the NSCF calculation from here, it will carry the spin orbit coupling that I have defined in the previous step. So this is the block-based architecture where one block information that is required in the other block is transferred directly. And that's why the ordering is important. So we first perform the SCF calculation without spin orbit coupling when we did the phonon calculation, but now with the spin orbit coupling, when we are doing the NSTF calculation, we have added this, we need to order this in the cell. And now you can do the NSCF calculation, and this will have the spin orbit coupling involved. As you can see, this is finished. You can, at all points, you can see your output or the input files that are being written by EPWpy by going into the folder where you have launched your Jupyter Notebook. So for example, I have launched my Jupyter Notebook inside this folder, and here I have the silicon, which is the material class where all the calculations are being performed. So EPWpy creates this material class, and here you can see that you have different folders where these calculations were performed. If you go inside the nscf.in file, you can actually see what exactly EPWpy has been writing for the inputs. And you can see that here it has added the non-spin orb, non-collinear and a spin orb equal to true. Basically, it's taking into account the spin orbit coupling, although we did not implicitly define in the NSCF calculation. This is how you perform this block-based calculations. And now, since NSCF has the spin orbit coupling, and the phonon calculation does not have the spin orbit coupling, we basically can perform the calculation from here onwards, and this will basically finish this block structure. So if I perform calculation from here for EPW, this will take time, so we will not execute, but I have executed them for you, and you can see that these calculations are finished on time. And here it has created output. We are not really plotting these outputs because this is just for demonstration how to run these calculations. For outputs you will have, and a good structure of outputs, plotting, you will have another video. Here we are only focused on running and how we actually arrange different blocks and how we create these blocks to perform EPW calculations. So this is the end of the block-based architecture.